setting up a unit reprefix conversion. A student sets up the following equation to convert a measurement. The question mark stands for the number the student is going to calculate. Find the missing part of the equation. Okay, so what we're given is 82, little dot there, 2 sig figs, right? This is newtons, it's a force unit per centimeter. Okay, so what are we going to multiply this by to get newtons per millimeter? So here's what you can do. 100 centimeters is equal to a meter. Or 0.01 meters is a centimeter. Each of those are equivalent statements. It may not seem like it, but they really are. There's 12 inches in a foot. There's a 1/12 of a foot in an inch. So these are the two that you could use between centimeters and meters. Either one will work. So what we want to do is we want to get rid of the centimeters, right? Our answer needs to be in millimeters. So let's begin by reprefixing it into meters. So centimeters is in the bottom. So that means we need to have the centimeter in the top. So either 100 centimeters in the top or 1 centimeter. I'm going to do the 1 centimeter one. And then in the bottom, 0.01 meters. Dimensional analysis, right? Units divided by the same units cancel. It becomes 1. So centimeters are now canceled. But that gives us newtons per meter, right? Not newtons per millimeter. How do we get it into millimeter? We reprefix again. So here's what we do. A millimeter is 10 to the minus 3 meters. Milli is 10 to the minus 3. So we could write it this way. Or that way. Or this way. Right? Those are all equivalent statements. 10 to the minus 3 is the same as 1 times 10 to the minus 3, which is the same as 0.001. So I'm going to use the top one, although any of them should suffice. And we're going to get rid of meters and convert that to millimeters. Again, we want to have the millimeters at the bottom. So let's write it this way. 1 millimeter is, actually I'm going to use the middle one. Actually, if you're doing it on ALEKS, I guess it's fine. 10 to the minus 3 meters. The meters cancel. And now we're going to have newtons per millimeter. Let's take a look at what happens to the number. If you take 82 and you divide that by 0.01, you get 8,200. Okay? But then if you multiply it by 10 to the minus 3, you get 8.2. How do I know it's 8.2? Well, let's convert this 8,200 into scientific notation. 8,200, the decimal point's right there. 1, 2, 3. So 8.2. Left is positive. So 10 to the 3. So if we have 8,200 times 10 to the minus 3, you have 8.2 times 10 to the 3 times 10 to the minus 3. These cancel. So you get 8.2. So our answer should be 8.2 newtons per millimeter. Okay? So there's 2 steps is the way I did that. There is a way to do that in 1 step. by noting where, and actually in my head, if I were going to do it, that's what I would do. I would do it in my head and say, look, milli is 10 to the minus 3. Centi is 10 to the minus 2. So this one's 10 times bigger. So if it's per millimeter, it's going to go down by 1. Instead of 82, it'll be 8.2. But I wouldn't necessarily recommend that, doing it that way, unless you were really good at doing it.